All right, so this is ArcGIS API for JavaScript, building classes using Accessor. My name is Rene Rubalcava. I work with the JavaScript team. This is, let him introduce himself.
I'm Yann. I'm part of the JavaScript team. Rene is really excited to talk about Accessor. I had to, for a long time, tell him, no, don't blog about it yet. It's not ready. So we're gonna talk about it, and then we did a brown bag internally for the team. It was for an hour, so we have quite some content that we had to squeeze in into 30 minutes. So yeah, let's get started. Yeah.
You go to your screen.
Yeah. All right. So first we're going to talk about what is Accessor, and then we're going to talk about how does it work. Not really, but yeah, we're going to talk about the public API of an Accessor object, and then how to implement it in both JavaScript and then in TypeScript. So when we moved to when we started 4.0, we wanted to clean up the API. We had some issues because we had some properties on some objects that you could access in a way, and then for other properties it's a different way. So if you want to access the extent of a map, you do map.extent, but then if you want to access the scale, you need to do getScale. So, but it's confusing because we want to document that as, you know, two properties. It's extent and it's scale. Why do I have to do? Why do I have to look for two different ways of getting those values? And then same issues with events. We have like extend change event, but then some properties on other layers, they don't have any events when they change. So, you know, it's confusing because the only way you can know about it is by reading the entire doc and memorizing it. So we wanted to clean that up and make sure that every property works the same way over all the objects. So this was really to improve the developer experience using the API. And then the idea also is that you don't have to focus about learning about how to deal with individual properties, but instead focusing on knowing what are the properties and what they can do when you change them. All right, so an Accessor. So we came up with, when we started doing that, it was like 3 years ago or 2 years ago. 3 years. We were looking at how we could solve that issue, and there was nothing, like no libraries that were able to deliver, being able to read and set properties and then also watch them. So we decided to come up with a class that had multiple different names, and then I re-implemented Accessor 4 times. Took like six months of my life, but we came up with that final solution, and we are pretty happy with it. It's not going to change for some time now. So when you create an Accessor, it means that basically you extend Accessor, and then your object, your class now has properties that can be read and set, properties that can be read-only, computed properties, and then all those properties are watchable. All the property values, that doesn't make sense yet, but they are cached in the object. So when the property is computed, the next time the code tries to access the same property, we don't recompute it, we cache the value and keep it until it's actually changed. So it's based on ES5 accessors. So this is how you declare a property. You can declare a property on an object in ES5. So you have your class, like here, person, and then on the prototype of the class, I will define the property first name, and then when the property is accessed, I will return a value. So Accessor under the hood access the value that is in the cache. All right.
Just switch me over.
Yep.
All right, so we're just going to talk about the public API for Accessor. Basically, how you use Accessor now in the JavaScript API without even knowing it, what kind of powers all the juice of the API. Like Yann said, I was really excited about this because there's a lot of stuff that we could do with Accessor that we just couldn't talk about yet because we didn't have some of this stuff finalized, but it's all really cool. So one of the really cool things you can do with Accessor is this unified object constructor. Basically, you don't need to pass in multiple parameters into your constructors anymore. We get one object, like with the layers, and you pass the URL, you pass an ID. Now in this case, we're passing opacity for the tile layer into a single object, and we're going to go and process the object behind the scenes inside the Accessor to instantiate the new class for you. And then you can also just go ahead and do the same thing when you use it, when you create the collection in the map views, map layers, and just pass it right in, and everything is going to work out really nice. Like I said, there's no need to be able to set multiple parameters anymore, which if you didn't know the APIs by heart, or if you didn't look at the doc frequently, you may not know the order. You would have to pass parameters. You'd pass a URL that may be null, and then a string, and then maybe an optional object at the end of something. So we got rid of all that stuff. Property access, so this is where things get really cool. You have a few different ways you can get to properties now by using the accessors inside the API. So for example, you can just access it via the property name like Yann was talking about, or you can also get it, and this skip to the bottom real quick, you can get it by the string of a nested property name. So a view has a property called map, map has a property called base map has a property called title. You can just go directly to the view, use the get method, give it the string of the chain you want to get the information from, and it's going to work very seamlessly. That's a great way to be able to get nested properties. You can do the, All right. You can do the same thing with set. So you can just say layer.title equals something. You're going to set that property, or you can set multiple properties on something by giving it the object with those property values and what those new values are going to be. You could set nested properties as well, like we have at the bottom here. If you want to set the property of the base map title from the view, you can do that, and it's going to work out beautifully.
Okay, let me, yeah, so the interesting part about the property access, when you read, a layer.opacity, it doesn't look different than any JavaScript object. It's just the way you access a property in JavaScript. So it's really nice because, like, if you deal with frameworks like Vue, for example, Vue.js, you would just pass the layer object, and then the Vue.js would be able to directly read the property. One other example we were looking at was like at the beginning of the implementation of Accessor, we started from Dojo stateful, if you are familiar with it. But Dojo stateful, to get and set property, you need to call a method get and set. And this is really like Vue.js doesn't know about Dojo stateful, so it doesn't know that it needs to call that function or get function to access the property. So that's why we are using ES5 Accessor, is that an Accessor object just looks like any JavaScript object.
Yeah, it plays really nice no matter how you use it. So property watching. So because we can watch for these property changes inside of Accessor, you have a few different ways you can do that. So instead of listening for events, and this is one of the things in the API too, we didn't want to have to try and expose events for every little thing you may be interested in. You may just care about when the center of the map changes, and when does the scale change. You don't have to watch for the extent change and then look for a center property after the fact. You only care about watching for what you're interested in. So we can watch for a scale change, and like Yann said, you're going to get the new property first, you're going to get the old property, you're going to get the property name, and then target in this case would be the map view, since that's what you're currently watching. Was it map view? It's map view, right?
Yeah.
The target, yeah. So the target would be the map view, and then you could do stuff with that in your watch statements that you're doing. You can watch for nested property changes. So if I want to watch from the view when the base map title changes, you could do that by doing the same way that we do for the get and the set methods, by just passing that string in there. You can also watch for multiple property changes. So you can watch for on the map view when the ready changes and when stationary changes. Then you can just do some sort of a switch case and watch for if it's ready that something changed, I'll do this. If stationary changed, I'll do that.
The idea behind that is that, like in 3x, for example, you get the feature layer, and then you don't know if the feature, like your function gets the feature layer, you don't know if the feature layer is actually fetching, pulling features, or if it's like doing nothing, because you weren't listening for update start and update end. So we remove those events, and instead we have the layer view for the feature layer as an updating property. So when you get the feature layer view, like the feature layer view, you can check that property, and then after, if you are interested by further changes, you can just watch for the property value. So yeah.
Yeah, and there's we have a utility module inside the API called WatchingPhils. We use it extensively in the API, but it has some really great methods in here that you can use. So if you've ever used Dojo on to watch for events and stuff, this has a couple of similar ones in there where we have like once, so you only care when this particular watch happens one time, you have that. We have pausable, so you can actually pause the watch handler if you want to do something else. This is useful if you're doing some sort of UI stuff, and then resume the watch after the fact. And there's plenty in here, like when defined once. The when false and when trues are pretty useful. If this saves you from having to watch for a property change that's a Boolean and do some sort of like an if true, do this, if false, do that. You just use the correct watch utils for when you want that to happen, and it's pretty seamless. Autocasting. So on the top of this sample here, when you wanted to create a symbol, you had to bring in a simple marker symbol, simple line symbol, Esri color, and you had to use the static properties on the classes, and then create new color, and everything had to be defined a certain way. Now, if you just create the symbol example here, something that provides something that looks like a color, something that looks like the outline, we know what they're going to be. So as you can see here in this example, we got rid of, we have a lot of strings now in the API to replace these static properties. So it's just square. It doesn't have to be symbol, marker, symbol, style, square. Color can be red, or as you can see at the bottom here, we have an RGBA value. There can be a hex value. Anything in there that looks like a color, we're going to autocast that to a color. And then the outline, we know that outline should be a simple line symbol. It's not going to be a simple marker symbol. So inside of the simple marker symbol, we autocast that outline to a simple line symbol with whatever properties you're providing. So you can see this all works out really nicely. You don't have to bring in all these extra modules now. You just need to define objects that look like what we're expecting them to look like.
All right.
And with that, head back to the man.
All right, so now we're gonna see how we implement Accessor in JavaScript. Everything that we will show is in a guide page in the SDK called Implementing Accessor. So we have like all the different patterns that you're gonna deal with, and we have the snippets in both TypeScript way and JavaScript way. So, all right. In case I'm going too fast. All right, so this is how you create a subclass of Accessor. You can call create subclass. People thought at the beginning that we invented that, but it's actually provided by Dojo-based declare. So declare, when you create a class, you have this static method to create subclasses. So we use that as a shorthand instead of having to import Dojo declare. All right. Then this is once I have my person class, I instantiate it, and automatically I have my the single object constructor. All the properties will be mixed in to the instance. And so after, if I to make a property watchable, I need to declare them. So we have these special properties when you create your class called properties. And then in it, you have to define the metadata about your property. So you would define its default value, a getter, a setter, its property type if you want to. So by default, you can pass an object which is an empty metadata. So you will have default. And then I create my new person, and I can watch for the last name. And then as soon as the user sets, as soon as the code sets the last name, then the watcher will be called. So I can provide default values by providing the value, right? That's pretty much it. And then we have shorthand. So if you provide one of the of the basic types like a string or a number, we will inflate that as an object with the default value John or the default value Doe. Then if you want to take advantage of autocasting, like autocasting a color object or an extent, you can specify a type metadata. So then after, if I set the extent with an object, automatically the code will see, oh, it's not an extent, so it will do new extent with that object that you have passed. So that's why the single object constructor was important there, because now all the classes are built can be instantiated exactly the same way. And then we have also, so Accessor has some capabilities, like for example, if you pass a value of a special reference, the code will introspect that value and see that it's an Accessor subclass, an instance of a special reference. So automatically it will create the metadata saying that special reference is of type special reference and its default value is WGS84. You can also specify, we have some other syntaxes, like if you pass an array with the type of the class, now we're going to know that fields, it's an array of fields object. So if I create my layer and I pass an array with simple objects, automatically all those objects in this array will be converted to field. And then we have the collection class. So collection is like an array but emits events when stuff are added or about to be added and then removed and so on. So you can invoke the method collection of type, then pass the class, and then automatically when you pass an array with objects, it will convert that array to a collection. Every item in that array will be converted to autocasted to a field object. Same if I call add on my collection, the object that I will pass will be converted to a fields object. View.graphics, for example, is a collection of type graphics. So if you pass just an object with a geometry and attributes, it will create a graphic for me. All right. So if you don't want to pass if you don't want to specify the type, but instead pass a function that will modify your value before being set, you can specify the type the cast metadata. So here I have an opacity. So I create a layer and it has an opacity. The default value will be 1, but then for my layer I only allow values between 0 and 1. So then when the user tries to set a value, I will clone that value between 0 and 1. So if I try to create my opacity with 45, it doesn't make any sense. So it's automatically converted to 1. Computed properties. So we have a lot of computed properties in the API. When you ask for the extent of the scene view, for example, that extent does not exist. We compute that value from the camera position, the size of the view. In 2D is the same. The map view is identified by the center, the rotation, and the scale. But so when you ask for the extent, we compute them. We don't pre-compute them every time the user pans. So what we would do is say that, for example, the extent depends on center, rotation, and scale. In this example, I have a person, and then that person has three properties, so first name and last name, and then full name that depends on first name and last name. When one of these properties changes, my property is marked as dirty. So the next time the code is trying to access that property, the getter will be called. So the getter here will return first name space last name. That value is cached, so until one of these properties are marked dirty again. Right. In general, computed properties are in general read-only, so you can specify read-only true. If the code tries to set the property, the code throws an error saying that you can't set that property. Then you can do computed properties that can be read and write. So in this case, you would provide the getter, and then you would provide a setter. So here I would set, so if I create my person with a full name, that value I will split the value, and then I will call underscore set. So this is an internal API, it's documented. It's when you want to set, you have underscore get and underscore set. If you want to manipulate directly the values that are in the cache. So here I will directly modify the value of first name with the first part of the split and then the second part of the split. So then if I try to access the first name, I will get the new value. All right. So this is kind of what happens when you set the view extent. We figure out what is the center and what is the scale and so on. We have some other shorthands. So we have alias of. It's very used in the widgets. If like for example, when you create a search widget and then you set the source on the search widget, it's actually the source of the view model that is modified. So we have an alias. So when I try to access the scale value on my class, it's actually the value that is in that chain. So my property sum, that has a property other, that has a property object, that has a property scale. And then TypeScript.
All right, cool. So yeah, so we're going to talk a little bit about how you can use the Accessor with TypeScript. I would say a solid 75% or so of 4x is written in TypeScript, maybe more at this point. So we use it quite a bit. And yeah, it's the better way to write your Accessor code, I would say. So because of that, we provide decorators. So if you're not familiar with what a decorator is, they're a way that you can just kind of annotate methods, annotate classes with some sort of functionality. So this is a little example here where I've got like an update method, but I've got a decorator that's going to be able to debounce that method by 500 milliseconds. So it's a very simple way to do it. So we got a little link here. So if you go out to the TypeScript documentation, you can look at a handbook to see how decorators work, how you can write your own decorator to do certain things like read-only and whatnot. Read-only is a popular one when you work with decorators because it's pretty simple to do. But there's lots of samples out there on how decorators themselves work inside of TypeScript.
It's a TypeScript feature, but it's going to be natively in the language. It's, I think, stage 3 right now of the spec. So it's still experimental, but hopefully it's going to stay. So.
Yeah, hopefully it doesn't change because then we'll really be in trouble.
Yeah.
So we have, because we want to make it as easy for you to work with the Accessor as possible, we have these decorator classes that are in a helper module you can use. One of them is subclass. So you're going to be subclassing a module. Use a subclass decorator on your class. You're going to use extends, and we have a helper method called declared, which works, uses declare under the hood to do the multiple class extensions if you need it. So you use that. And then instead of providing a properties metadata object, you just use this property object on your properties in your class. By doing that, automatically we know you want to watch that property. So if you were to do a watcher on it for any changes, you can, and we'll be able to watch changes on the property. And then there's more you can do with that.
Let me comment. Yeah. So the subclass and declared stuff are really because we needed multi-inheritance because we have mixins for the layers, for example, and this wasn't native in TypeScript, so we had to walk around kind of it. So it's some boilerplate, but the idea is like a subclass will actually use declare to squish all the classes that is in that declared call.
Yeah, and there may be some changes to this down the road with the TypeScript, the recent TypeScript releases that may let us work around some of that subclassing, but for now this works just perfectly. And I believe we're still good on time, don't worry about it, other people canceled. So these are how you would bring in all the modules and stuff you need to use the decorators and stuff from this TS support declare we have in there. So we're showing an example how you extend the scene layer, we create interface for the scene layer, and then what we're going to do is that interface extends a couple of other interfaces that we have. Then we're going to use a subclass method. You don't have to provide the string name for the module in here. We do, just so that we internally know what these modules are. And then you extend these, do the extends with the declared method, passing in the actual instances that you want to extend. And then you implement your interface that you define so that you have a contract set up that inherits the interfaces from everything that you're extending. This lets you do in your TypeScript code, you get all the IntelliSense and your editors and everything, and things work pretty nicely. So if you want to define property types, so just adding the little declared property makes a property watchable. I'm sorry, the at property makes it watchable. But you can also pass in strict typing in there. So you can say it's going to be a type string. So if you try and set it to a value of a number, you're going to get an error in there saying it won't create a number for you. If you try to set it to an object, then it won't do that as well. So you can really strongly type all of these in here the same way you could by using the metadata properties in JavaScript. So computer properties work very much the same way. So you start seeing the patterns in here. The way that we did everything with the metadata properties that are inside Accessor in JavaScript, you just do them in here as well. So we have depends on first name, last name, and then when you get the full name, we're going to say that we're getting a string back, and you just return the two properties concatenated together with a little space in between. Custom setters, you can do the same thing with the custom setters in here. So I want to be able to set my opacity in here with my value number. And it's going to go ahead and do a set on the opacity once I've gone ahead and computed out what I want that value to be. So I can restrict my setters to, in this case here, make the opacities between 0 and 1. And that's because if you look at some of the opacities that I think they're in the Esri JSON, they can be between 0 to 255. So we kind of have to compute that 0 to 255 to be between 0 and 1 instead. That lets us do that. That's part of the beauty of using the Accessor for that. So custom type cast properties. So we saw the cast earlier, and this is pretty much the same thing. We just have a cast decorator that lets us cast a property, and we're going to create our little method here, and we're going to do, again, restrict the values between 0 and 1, so you can't go some ridiculous number in there. Read-only properties. So again, we've had two properties here, read-only, but then we have an update method on our class that's going to be used to do the updating. So you can restrict setting of the properties to something like this method and only allow the values themselves to be read-only. It's a nice way to kind of contain any kind of changes inside of your classes as well.
Yeah, so the underscore set does not verify if the value is if the property is read-only or not. It's you can call it as you want. It's read-only is only on a public set. So if you try to call if you try to access, like set the property directly, now it's gonna tell you it's gonna prevent you from doing that. But underscore set, if internally you need to set the property, yeah, you can do that.
Don't try it on your own on some other Accessor property. You will probably have bad results. The proxy property, this is the same thing with the alias of. So you just tell it that you're going to use this a lot with the view models, or actually the widgets, where you'll see it if you look at the custom widget development session that's here, where you create a property with an alias of to some nested property that's on the widget or on the class itself, and just call it numbers. So you have to. This saves us from having to tell you to access view.popup.viewmodel.something, just so you can go directly to popup dot whatever the properties need to do. And that was the last slide.
Yeah.
So we're open for questions now. We hit it just before the 4:30 mark.
We have time because the next
there's no one coming in.
Is canceled,
so is there any questions here?
Right. Can you, yeah.
Come here.
We're gonna repeat the question.
Is it possible to get hold of just the Accessor class and use that in 3 to sort of forward protect myself, or has it got too many dependencies to do that?
It's not impossible. It's not. Yeah, we are not targeting at doing that. It's gonna be problematic because since we are using ES5, our build needs to be of 3x. It has to be compatible with ES3. So. Yeah.
Any other questions here? Any other hands? There's a lot of material to condense in 30 minutes. This normally goes into like a full hour, hour and a half.
Those slides are public. They are on GitHub.
Switch it to your thing.
Yep. Presentation. Yeah. Yeah.
Yeah, so if you're interested, you can get the slides there.
Yeah.
Study them. Yeah, but using Accessor on your own is pretty powerful as well. I can actually show you I'm going to show this in a TypeScript session later, but basically you can do some cool stuff like use it as a data store for your application. So in this case here, I create a very simple store, and I'm typing out a couple of things like the web map to Esri map, view to map view. I have a couple of properties just to watch for when they change, and I have a little method here that's going to add elements to my UI on my store. And I can then use that store throughout my entire application to do things like in my view model, I use the store of the view model to watch for changes, and I can make a cool little charting app based on when the store gets updated. So I go through here, and the store is just in charge of finding out how many facilities are currently in my view, and update on the fly kind of thing. So you can use Accessor to do quite a few things inside of your own applications as well. It comes in pretty handy. When is that session? I forget when that session is. Tomorrow, I think. Yeah, tomorrow. Tomorrow's, no, Friday morning. Friday morning, TypeScript. Oh, I'm sorry, we can't hear you. Yeah, come on.
I saw what you did with the layer list and how you decorated the layer symbology.
No. In that case. So the question was, is that what we use for the layer list in the plan area to add those custom buttons and stuff? That's actually something we're doing with widgets called actions to create custom actions and stuff. You can do it with the pop-up and layer list now, and you can basically add buttons into items in the layer list and do something with it. In that case, it was used to change the renderer, but you can use it to make a opacity slider or even change the source of the layer. Probably, I haven't tried that. That'd be kind of cool if you could do that.
We have a sample in the SDK about this called layer. If you search for actions here.
Remember I showed you yesterday how I use a trigger action to actually show a legend symbology when you click on it from the layer list. It's a trigger action.
Well, you could do that. You could technically have a layer list action that will go out and get you the symbology for the layer you clicked on. You could try and do something like that by using the legend view model. But we haven't done that, but theoretically you should be able to do that. It might be a little tricky, but you could probably do that. Yeah. All right, awesome. Well, thank you very much, folks. Appreciate it.